Hi, and welcome back. My name is Dennis. Now it's time for Foundations Core Systems Component Commands. Today's learning objectives include understanding the file descriptor operations, utilizing common utilities from the command line, and manipulate files and data using command line piping. Let's go ahead and get started. First things first, we talked about in the previous lectures how data gets interpreted from the CPU, the hard drives, and the hardware ultimately getting processed by something. Let's talk a little bit more about secondary storage and the hard drives that go with it. Hard drives are secondary storages that are considered block storage. So when you think of hard drives, think of block storage. Block storage is just really dumb storage. Metal storages of physical drives of data that really has no idea about what kind of structure there is. It just needs to know how to insert ones and zeros in one or more blocks of its storage capacity in unit. In tandem with that, we have what's called file systems. Now, file systems are really an essential source of an operating system itself. Remember that operating systems include applications, file systems, kernels, device drivers, many different applications and many different components that make up an entire operating system of choice. Some of our examples of file systems include NTFS, EXFAT, EX5, HFS, APFS. So APFS is Apple File System. HFS is the hybrid file system. Extended 5 is a file system known for Linux. EXFAT is kind of a universal file system, but also primarily from the Windows days. EX meaning Extended File Allocation Table. And NTFS primarily for Windows use cases. Each file system is really geared towards, just like the kernel, towards an optimized solution for that operating system need. Hard drives need to be partitioned and formatted with specific file systems in mind so that you can actually put data in a logical path that the operating system can read. So let's think about this a little bit more carefully. I have a hard drive, block storage. If I partition it with a C or a D drive, such as Windows, I could still have NTFS on one side and then maybe FAT32 or EXFAT on the other side. Both are still logically different drives, similar to how you mount different portions in Linux. But also, both have different logical partition spaces where this is probably better for my operating system, and this one's probably better for my files and data that have to go between different operating systems. Not every Linux file system or Linux operating system can read NTFS out of the box, and so most might be able to read FAT32 or EXFAT out of the box. Ultimately, how you need to devise operating systems and file systems as a distinction is that operating systems contain file systems. They read from the file systems and it creates that structure that the operating system reads from. So for instance, in the user space, when I open a file, I have a directory structure already created. The file system created this directory structure. File system. So such as EXFAT, NTFS, ext5, whichever it may be. And ultimately, the block storage, the secondary storage, the block storage, goes and the table references the table from the kernel inside operating system memory and says, hey, pull these blocks for this file and then be able to read it. Similar is done when you need to read a file. An index is created and says, pull these blocks again, not just loading into memory, but also process them into your text editor or whatever you're going to read it into standard out for. The main goal of this is that you need to understand that file systems create the directory structures, the tables, that reference where data is inside of your block storage. That's all you really need to remember at this point. In a more simplified example, if you want to see how block storage is stored, a disk of blocks may contain 4 different ones for one file. And so really, when you're being requested from the operating system, the file table, hence we have FAT32, right? File allocation table, potentially, has a list of those blocks relative to the name of the file and how far that file is. So you might have name of file and the size and range, right? Where those blocks start and end, or if they have to go on different portions of the block storage device, that's what they'll reference. That's all file systems do. They link and provide directory storages and storage information about the data stored in the blocks of a hard drive. Hard drives are not smart. They need a file system to compare with, otherwise your operating system can't access that data. Now, Linux file hierarchy is a little bit different. So in tandem with your operating system, once it can read the data on the disk, it has common structures. So if you think about how Windows is operating, it uses C, then there's a Windows, there might be a users, and many other folders. It's very similar to how root starts with C, the C equivalent inside Linux, and then it trickles down to multiple folders. Each folder has its own separate need and use case, just like Windows does. The /bin folder is usually made for binaries for you to that's default to the operating system, while under user /bin are where you install your binaries. You install binaries or applications specific to that user or for made for other users to utilize. We also have main ones like temp, which is for all temporary scratchpad needs, which anyone can read and write to. We have the home directory, just like a home of a Windows user, for profiles and where you want to store your local items. Just like in program files inside C, we have etc. So C/program files is the same as etc. Right? It's the same as etc. And etc contains a lot of the configurations by default of where your applications might have configuration and other details in file format. We also have sbin and many other directories of interest. Sbin means only super users can access those binaries and use them accordingly based on classic Linux administration needs. There are many more files and structures to really think about. Let's focus on these three. Under the var and log, we have where everything gets logged to from a file standpoint and from an application standpoint. User binary directories are really for when you install applications, all those accessible by other users or not. Finally, your home and desktop, based on your username, is where you have your play space to be. Wherever you need to put temporary files for your experimentation, you should put them in there and not anywhere else. Because why? In case there are upgrades and in case there are changes in the operating system, these directories can get overwritten based on upgrades. These directories under your user paths tend to only get changed based on the actual runtime need. Now, based on files and directories, and that we have files that are either data or not, or executable or not, we have what's called file descriptors. Now, file descriptors have multiple things. If I have a file of data 1 and data block 2 and data block 3, and I carve it all up, and I print that out to my screen, we'll pretend this is a monitor, that is standard out. And so that is represented by a 1. If I input data from a keyboard, and I'll just clear this up real quick. If I input data from a keyboard, let's talk about input, into a command or anywhere else, you can actually call it standard in because it's going inbound. Now, what we mean by standard out and standard in is exactly that. Standard out goes to a printout, usually on your screen. Standard in is something that takes input from your keyboard or data or another file and uses it as input for the command. Now, those are considered streams, and the last one is standard error. So if you ran a command and you ran it with the wrong syntax or something happened, standard error is also a stream. And those can be any one of these can be redirected to a file. In fact, you can even redirect standard in from a file to command. So if I have a file here with data, I can redirect that using the opposite arrow for standard in for my command. So notice that this is going to the right, which means redirect anything going outbound to a file so you can maybe capture a log or some status code. You can actually use input from a file to be your standard in instead of you typing it on a keyboard. That's all it really means. So keep in mind, standard in, 0. Standard out, 1. Standard error, 2. And these are all streams that you can also redirect into a file or from a file where necessary. If you wanted to redirect all standard output and errors, we use a special version of that using 2 and 1 into the same string. So redirect standard error into standard out, and you can also redirect that again into a file using the notations of the arrows. Now let's look at some common commands. We'll touch on all of these throughout our module. We have cat, which means basically concatenate, view a file. We have cd, which means change directory. cp means copy. File will actually do something quite interesting. That one actually says, hey, are you the correct file that we think you are? So if you had something that was perhaps a something.zip, you can rename something as something.zip, but you don't have to actually be a zip file. So file will actually check against the database and see if that's actually a real zip file or not. Next in our lineup, we have we have find, which means we're going to go find a file. Rep, which means we can search one or more files or even directories for a specific content. We talked about zip, which means we have an unzip and a zipping procedure. So just like gunzip, you have a gzip. It just means what it sounds like. You can see just like standard out with cat, but you can also get off the top portion of the file. So if you have a very long file and you don't want to go scrolling through it in your terminal window, you can open it in head and only print out the first 10 lines or so. We also have less, which says, hey, instead of cutting everything out into my standard out, put it into something that's standard out, but I can scroll up and down on it for. ls is saying list system, which means to list all your files or objects inside your folder and the attributes for them. The man page is not what it sounds like. It's actually short for manual. So if you say, hey, I don't know how to use the cp command for copy, you type in man cp, and that means, hey, show me the manual for the copy command. You have make directory, which means you're going to make an empty directory. Nothing more to that. mv means move, so you can move a file and or directory from one place to another, and you can also use the same one for renaming. Nano is a text editor for ease of use, and you can actually text edit things in the terminal without installing a GUI. PWD means print working directory. So if you're ever lost and you need to drop into a terminal or shell and you don't know where you are, start with PWD. Sort will sort anything that is standard, taking in from standard in into a standard out into a sorted mechanism, alphabetically by default. Tell is the opposite of head, so you can capture the last tell of a file if you want. Tar is to kind of like zipping something up, but it doesn't actually use compression. Just basically says, hey, all of you files come into one file, and then you will use my algorithms and items to expand that file back to your normal multiple object sizes and needs. Touch allows you to touch a file and update its modified access and other timestamps, but you can also create an empty file based on touch. The VI and VI improved is VI modern, is actually a text editor much like Nano, but it has more powerful features and shortcuts. It has color codes and commonly more often installed than Nano in many operating systems, Linux operating systems at least. WC stands for word count. So we'll have word count, lines, bytes, even character counts. Echo is exactly what it sounds like. It'll echo whatever you put as standard in into standard out, and that's all it does. Cut will take whatever you have from your standard out or your file and show you in standard out whatever you only wanted to see. So it will cut only on one column or field. T is a very special application where it will take output from one application, show you in standard out, kind of like a duplicator, and also redirect that standard out into a file on your behalf, really good to use when sometimes when you need to be in a pinch where a center out just won't redirect correctly without with the normal carrots. So with that, let's take a small break and let's do some demonstrations and get back to our demonstration here. Hey, welcome back. Hope you had a great break. Let's get back to our testing and tuning and experimentation with the Linux command line. I have my terminal open inside Ubuntu, again, inside our Type 2 hypervisor as we discussed before in previous lectures. I encourage you to pause this video, turn on your Ubuntu VM or other Linux-based VM, and open the terminal and follow along with me. All right, let's get started. If you don't know where you are ever, try whatever directory you're in. Sometimes you can see the prompt here that gives you a little hint, and here I'm in my home directory, but it's also noted in a shortcut called tilde, and I wouldn't know that unless I do print working directory, and that's saying I'm in my home directory on my desktop. Now what that really means is I can manipulate and do stuff here, and icons will show up. So if I say echo something here, some file.txt, sorry, let's try some temp file.txt, right? You should see a refresh, and I can actually see that file on my desktop accordingly. That is where you can see things on your desktop if you need to do things in command line along with your GUI. Let's go ahead and remove that because we don't need that anymore. Now, one of the things that we used was change directory to move and navigate between file directory hierarchy. So I'm going to go to the root directory, and I'm going to use a command called ls. This gives me a listing of folders and files that are not hidden. And as you can see and reference back into your hierarchy, right, we have the binary, we have the user, temp, and many other items of interest here. Let's see if we can go into /etc. And we'll do an ls, and we have a bunch of configuration files that don't really mean to you much right now. They will shortly. Yeah, let's look at one of them. Let's use Fuse, for instance, or let's look at fstab. So we'll cat fstab. And here we have a configuration file that is related to automatically mounting on boot my file systems and other aspects for the mount command. Now, if I want to go ahead and try to edit that, we'll see that it does not work. And we're saying that this is read only. And if I try to add something, and we're using the vim or vi command, a for append, and we're saying add something here. We'll try to write to it, quit, and we're saying read only option, try to override, but we don't have those permissions. To see why we don't have those permissions, we can do an ls again. Let's clear our screen using the clear command. ls lah, which means long lengthwise, all files and human readable. And we have everything in our directory here, who the owner is, what our permissions look like, the date creation, and the sizing in human readable format, bytes to kilobytes, as we saw earlier. But I really don't want to see everything. I need to see only what I wanted to see, which is fstab. So we'll just say that. And we're saying root and the group of root that's inside the root group can only read and write, and we can only read for anyone else. Well, we're not in that group. See what kind of groups I'm part of. We'll do groups, and we'll say DW Chow, which is my user. I can also say confirm who I am. Who am I? I'm in a pseudo group, but I'm not in the root group, and that's probably for good reason because I'm not root, and I shouldn't be touching those configuration files where necessary for my own safety. I'll use the tilde command to go back to and then /desktop. Use tab for autocomplete. I'll clear it again, and again I'm back where I need to be, back to some sort of safety. Now, one of the main things that we have to understand is that you have the binary folders where default files are. So I can go which ls and say, where is my default ls? And there it is. It's going to automatically, if I say the word ls, it's automatically going to reference this folder path directory. And of course, this was a key folder as we looked at in our previous lecture slide deck. Now, one of the things we wanted to know is that we wanted to be able to move files, rename files, do something with files and directories. So let's create a directory here, some dir. Notice that it just got created right here. And then we're going to go ahead and put a file in there. So we're going to touch something, but we're going to say, hey, dot forward slash means this folder, this directory, print marketing directory I'm in, reference some dir. Oopsie. So make dir dot slash some dir. And then we're going to say, we're going to touch a file and we're going to touch it and create an empty file inside there. And we'll say touched file.txt. Now, if we go and cd into some dir, working directory, we have our listing, well, ls again, and we'll cat touched file. Again, dot forward slash means reference this directory. And there's nothing in there, obviously. We can use redirecting our standard out into our file descriptor and append that file. So instead of overwriting the file, we can append it and we can say hello world. Use our double caret touched file. And now we go touched file, we have hello world plainly listed there. We can also rename the file using what we call with move. So other than moving it, I can move this touched file to one directory up, which means dot dot. And now it's inside. I don't have it anymore. I'm also saying cd dot dot go up one directory. Now I have in my desktop again, and now it's been moved out of that some dir directory. I can remove it, and it's not going to work, and I'll show you why in a second. I can remove the directory with rm, and lo and behold, I can't do it. I can use the man page, which is manual, and read up about removal, and it's saying, well, all kinds of stuff, and I don't want to scroll down. That's a lot of stuff. So I wanted to look about something about directories. Press the forward slash key, type in the word directory, press enter, and it's saying it's finding anything highlighting the word directory. And I don't have anything quite yet, but it did get me somewhere here. It said remove empty directories. I can also press next and B for back to go up and down based on my findings, and it'll highlight my keywords for me. So type in -D, and it'll go get me direct to my option directory. Remove entry directories. We got exactly what we needed. Q for quit. And we can also do rm-tech help for information about how to use it, as you can see here in some of the README examples right there. Let's clear this again. ls, and I want to do remove -D some dir. And boom, it's gone. Exactly what we're looking for. Touched file, and it has read write for everyone and read for the rest of the world. I'm not sure I want that, but we'll touch on that on a different lecture. Let's rename this touch file. So if I cat it as hello world, we can also rename it as touched file and then say rename it to hello world instead. Now it's been renamed simply, even with the move command. So know that move can move files and directories as long as you have the source and the destination file name accordingly. And one thing to note is if I moved it to touch hello world to /temp, right? Now it's gone. And if I do an ls lh, even though I'm inside my desktop right now as a print working directory, /temp hello world, and I get exactly what it is. And I am the owner because I created it, and everyone else can read it now. I go to /temp. I'm in the temp directory, and all this will be blown away upon next reboot. But how do I get back? Well, I can use the tilde that references my home directory, print working directory, and I can always do cd desktop, and I'm back at my desktop, lo and behold. You can always go to cd / to go at the top of the root, or cd .. to go back to my home directory where I can save all kinds of stuff, just like I did with Microsoft Windows. We'll open up C desktop again, and we'll clear that out accordingly. Now, let's look at a little bit of other things too. Let's go back to C home. The home directory. ls lah will show us everything. And I'm saying, notice that these don't show up unless I do lah. And that's because I'm not showing all files. These dots in front mean these are hidden folders and hidden files. To confirm this, let's use ls by itself. Makes sense. And of course, LAH shows us way more stuff, including our permissions to the left, our owner and our group managers, as well as the sizes. And notice that when we reference something, even if it's saying, hey, reference bash history, if we want to reference catting bash history, in fact, let's just use tell. Tell the last 5 lines of a particular file. We're going to use // saying this folder, which is my home directory, and then the dot right after, saying that this is a hidden file of bash history, and voila, we have Dennis using who am I, exit, ID, and who am I multiple times in that bash history. Quite neat here. One thing to note also is the profile file. Notice I use a lot of auto tab completion. You can do the same thing. This is set for anything to actually run on startup when you log in, hence your profile. So profile, some settings for your environment, all kinds of interesting stuff. I'll press quit. And you can also look at bash RC, which is anything to run on your startup upon login, not just your environment itself. So you can add stuff at the end, and it's just one large script. We'll quit here with a Q or less commands, and then we'll continue forward. If I wanted to do tell, we just showed you tell, so I can say tell-n 2, last 2 lines. Now, if I didn't know, again, that's man tell or tell tac help, which will give us a quick summary of what's going on. Okay, so we've gone a little bit more about files, creating files, moving files, and manipulating files. How do we copy a file? And how do we copy multiple files at the same time? Well, let's go on my desktop, and I have some file 1 and 2. Something funny, and oopsie, number 2, something funny, also copied. I want to copy both of these to temp. I also want to copy the demo files along with it. So I can copy individually, which is source and destination. So copy some file .text, just like we did with delete and move /temp. And of course, we have our /temp some file accordingly. We can also copy everything from our desktop to temp and clobber it. And we'll say copy -r desktop. All right, so let's double check what our directory is, which is desktop. Copy -r /* which means wildcard for everything /temp. And now we've copied everything for temp, which we should see everything we need, and it's quite jumbled up here. And I don't want to see anything other than our some files. So let's do an ls filter for anything that has some file .text. We have R2 here, and of course we want to see demo files, so we want to see anything that with the word demo in there. And of course I did it to the wrong one, so we'll do that to the correct ones to make sure it got copied over, and of course it did. So we'll go, remember that I have to use demo with a capital D because why? Case sensitivity. No such file or directory? Well, because there is not a file, just a folder. So boom. We have /temp /demo and anything with the word demo in this name, but it clearly did not show exactly what I was looking for. But the interesting part is there is a demo folder. So if I go to temp /demo, it did show me everything that was already in that demo folder, which was kind of funny. So you got to really understand that when you're doing masking and wildcards, you're actually just doing it based on a prefix, suffix, or a name. And you should do it on files, not directories. Let's go back to our desktop, and we're safe once again where we need to be. Now I want to show you a couple things I showcase, which is editing a file instead of just using echo to append a file all the time. For that, you can do a sudo, if you don't have it already, go ahead and do a sudo apt install vim. I already have it. And what this basically means is install this application from our known package repos, and we'll have more explanations about this on a future lecture. I already have it, so it's already here. So you can run, I'm in my desktop, I'll do a vim, some new file.txt. And now it's going to create a new file in temporary buffer holding, and it's hidden, even though it hasn't created yet. I can go A for append, and I can add stuff and press escape, press the the colon feature, W for write, Q for quit, and it's just like doing the echo command. Now the interesting thing about Vim is that it's actually got much more powerful than that. You can always do A for append, but here's the thing: you can hit YY for yank, which is the equivalent of copy in Windows, and you can go A append and move between lines. So I'll move to the next line, press escape again, so I'm no longer, and I'm going to say P for paste. Paste, 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 paste. And wow, that's sometimes a little bit faster than using a GUI sometimes. So, and then of course I can always delete. Now, if I didn't want all these lines, I can go hit the delete key, delete the D key twice for delete. I can delete by line. Again, I can do a colon after pressing escape, press the W for write my changes to the file, and then I can finally quit if I wanted to do in 2 steps, and I'll cat new file. And bam, we have a great way to do this. There's another tool that's default installed already in your Ubuntu if you're using that, called Nano. And this allows you just to delete everything as if you were using Notepad. You can use your arrow keys instead of using home and append and all kinds of stuff. Press Control X to exit, Y to save, enter, and there you go. A little bit easier, but different sets of commands, all depending on your choice and needs and requirements. All right, so what did we capture from all of this? Well, we captured how to edit files, redirect file descriptors, and things like that. What if I wanted to pipe something? And what is pipe? Pipe is really a way of saying redirect anything from standard out. So if I said standard out, new file, and that is considered standard out. If I redirect it to another file, I can certainly do that. Or I can redirect it into another utility or command. Instead of redirecting it into a file, I can redirect standard out as a standard input, right, into another command. So I can redirect it into the word count and count how many characters there are with the -m switch. Again, use tech help or the man page for more information about these commands. I have 201 characters across the entire stream, which is really cool because other than that, I mean, I could have just done word count on the new file, but if I had multiple files, I could run it accordingly. But this shows me the same exact thing, but I can actually take standard input, redirect it to standard output accordingly. So if I have standard output of all these, redirect to the standard in, and my pipe is word count, and that gave me the equivalent of just opening it directly. So this is much more efficient, but this gives me an idea of what I can do in the near future, as we'll see with our some advanced usages of the pipe. We have files. We have actually quite a bit of files. So ls.txt, and we have 3 of them. What if I wanted to make them into one file, not concatenate them, but keep them separate? I just want to conserve the number of files I have on my system. Well, to do that, we use the tar command. We'll want to go ahead and use tar-v for verbosity, C and F to create a file package. And we'll say my tar file.tar. And we're going to specify all the txt files in this current directory. Boom. And now, you see very closely here, this came with my file tar. If you open it up in the GUI, it actually has all these files contained inside this one file. And if you actually look at it, think about what we just did. We're just containing files. Pause the video and really think about Did I save any space from a file storage perspective? I'll wait. All right, do you have your answer? Well, let's take a look at how we can verify that. LAH, start.txt, and we all have around 201 bytes, 286 bytes, 309 bytes together. And you do the math, it'll roughly range into the kilobytes. If we do an ls/lh mytar, we don't have any real savings there. We just have it as a container. So if you combine all of them together, we only have so much kilobytes. And it's not meant to compress. It's just meant to contain, right? To create a grouping of. To actually going to do in compression, we have to actually zip it up. Because zipping has compression algorithms designed to be contained around multiple files and folders. To do so, we use something called gzip. We'll gzip the existing mytar file, but before we do that, we'll use a magic file command to determine this is a tar file. Now we're about to gzip it. So we gzip it, and now it's turned into a new file entirely. It didn't just add and rename the tar file in a suffix. It actually did change the contents accordingly. So now it's a gzip compressed file using this algorithm. And then now we can actually look at the ls/lh mytar gzip file. And we can see that we compressed from 10K to 292 bytes. An amazing compression routine. All right, if I wanted to remove all text files inside this directory, which is, let's print working directory first. All right. Text files, boom, we're gone. And now we only have our single gzip tarball. Let's unzip it. Now it's back to a tar. And then we'll use a couple of different switches with our tar. Again, man the tar page. We'll use extract V for verbosity and F to define the file that we're targeting. And now we're back to normal, just like it was beforehand. And we can remove the original mytar file as we see fit. One last thing to keep in mind is I wanted to showcase different ones, including what we wanted to do for grepping and finding files. So let's look a bit further into doing more with our files. We have our different files here, and we cat some file. We could certainly look at it each time and maybe head or tail it or something like that, but we can't figure out what's actually in those contents. To do so, we use a actual tool called grep. So if I know what I'm looking for, we'll use -I for case insensitivity. 112233, or actually 1222. We'll create our grep our output, and we'll grep recursively. So we'll grep all files, and we'll say this folder, including subfolders of this folder, for anything with the asterisk.txt. And now we have some file that has two sets of IP addresses, a 33 and a 44, and a 44 and a 45, and 3344 in some file too. And that's quite a bit of powerful tooling. Now, let's think about our use case of piping. Let's say I wanted to only grab the right side of that output. Well, while we can use piping, we didn't showcase cut necessarily. So let's cut it. I only want the right side, and it looks like to me we have a colon right here, and we have a left side and a right side, and there's only no spaces, and it's the limited bicolon. I only want the IP addresses here, Internet Protocol addresses. Those are what those numbers kind of stand for, although they're not accurate numbers for obvious reasons. We'll say our delimiter with a -D. Again, use your man pages. We're going to say in quotes here, colon is our delimiter, and I want the second field, or F2. Now we have our IP addresses. Very cool. And so you can really think about how powerful this could be utilizing piping in an advanced way, saying, well, if I had to take standard input from a file of IP addresses, this could help me get there a lot faster using piping, and this is actually a form of automation. Now, we don't need to grep the entire structure. We can also grep an entire folder without text files. And we can actually grep starting with the home directory, or maybe even temp. And we can grep recursive in case it's stiff, and we can say foo. And wow, it matched a whole bunch of stuff, and that gets even crazier. And I notice that we have a permission denied here. I don't necessarily want to see that if I'm going to do some automation. So if I don't have permission to see it, I don't really care. Again, file descriptor, I want to redirect the standard error stream to a special place called dev/null, which also actually acts as a way of saying, don't show me any errors. And now you can see here, I don't have any errors. I do have some binary non-matches, and I don't want to see those either. I only want to see the left and the right of what you did match. Okay, well, let's look at grep again, and let's find how we can look at only what we want in output. Well, we have a couple options here, but luckily for me, I know what those outputs look like. So you can read up on it. I'm going to clear it, and I'm going to use case sensitive recursiveness. And I'm also going to use -O for saying only match the output. There we go. But here we have another issue here. It's only showing me what it matched on, not the entire line. But now we have binary matches and non-binary matches, and I don't want to see that either. So let's go back to our drawing board. And we can say /binary to search for the term binary and see how it gets treated. And we have process of binary as if it was text, binary files, garbage. And we can say, oh, as if it did not contain data, this is equivalent without the option. So I need a capital I here in my case, Q for quit. All right. So now O, we'll use capital I. Now we have everything that we want minus the term binaries at the top. And we can also pipe this again, head 3 to get the first 3 lines for the only, we also don't have the color. And of course, if I wanted to get my results, you can also put this in the cut. The first 5 lines. And then we know what our data looks like already. We need to use a -D and F parameter switch and look at the second, and boom, we got exactly what we're looking for, which is the payload of our matches. So you can play around with that a little bit more, but let's take a look at what if we knew something about the file that we were looking for, not necessarily what's inside, but the file attributes, sometimes of name. Well, we didn't know. Let's look for a password specific file. We knew the name and we wanted to look for the word password in the file name. We can say find. Let's start from the top, which is our source, which is the root, and we want to look for it recursively. Find is going to look at it recursively. We're going to use a name attribute, which means I want to look for the name password, and with anything that has the word password in its name and as a prefix. And we can also say any name period before or behind as a wildcard. We also say type, which is a file. And we can click on go. And notice it's getting really busy with permission denied errors. It's lots of standard errors. So we're going to Control C, which means stop it at will, clear that screen, use the up arrow key twice, get back to what we need, and we want to redirect standard out to dev null. And let's do that again. And now we have all kinds of stuff that has the word password in it without any of the errors. And it gives me the great absolute pathing, and I can explore those further. So absolutely perfect. But in particular, I wanted to look at one particular file, and it was starting with the Etsy, and which is password. If I do a cat on Etsy, lslah on Etsy password, we see we have read-write access as the root owner only and read access for everything else. And, well, that means we can actually tell it or cat it. So let's tell it real quick. Wow, gives me information about my username. I don't have any password credentials here, but maybe we can look at it at some other point in the upcoming modules. All right, we looked at grep, we looked at finding for help, standard redirection, and then we're looking for very particular sets of items. I don't know how many of these lines are there. Well, we can always pipe it into, how about we cat Etsy password, and then we'll count it to the number of lines, and we have 46 lines in those entries. Very cool on the statistics. And then, of course, we also have very similar ways of doing this inside PowerShell inside Windows. So if we want to do the same thing in Windows, let me bring it over here. I'm going to make the screen just a tad bit bigger with 18 size font. And then let's go ahead and get started here. So let's make sure our font actually is in a relatively great size. Awesome. And then we can also look at the downloads. And that's quite a bit of downloads. I don't want to do that. Let's do this. Clear screen with just CLS, or you can do clear. And you can also do this. Let's echo something funny. Redirect that same thing into center out text. And instead of cat, we just have a get content center out.text. Boom. And then to actually measure that, we actually have to pipe it into measure object. And this is PowerShell, not DOS. We'll auto tab here, object. And now we see we have a count of 1 line, and that's how it's going to measure it. If I did a echo something funny, 2, and get content center out, there's 2 lines, and so measure object will count 2 lines, which is the equivalent of word count right down here. Now, we can also do a couple other things with this. And so we can also search through it. We can do additional sorting. And if we did, we looked at the head, it's not in alphabetical order. So let's do this. Let's sort. And notice that there's going to be something wrong that comes with this. It still doesn't sort it in the way I want it to. Sometimes. When this time it did. But the safest way is to sort it directly against the file, because you're saving a pipe. So I want to sort it directly on the file itself. So I'm not making sure I'm worried about the streams. And notice that it's now in alphabetical order, and roots and www is at the bottom. And then all of these appear to be a unique line, so I don't have to really worry about that. But the interesting thing about sort, before we roll off on this, is that if you look at some file, well, we have repetitive lines and it's not sorted. So we can do a sort -u. And now we see sorted by the space, followed by the numbers, and then the A to Z, and only unique entries per line. So that's it for today's lecture. I hope you enjoyed it. Please do experiment further with your demonstrations and your labs, and hope to see you again pretty soon.